Yeah, we'll talk about everything, I guess, a bit of AutoGluon and then AutoGluon Assistant. But thanks to the AutoML school team for having me here. And I'll today basically talk about what we've also talked about a little bit yesterday in the 2 afternoon talks by my fellow speakers, Jennifer and Palash. So it would basically be me drum rolling on the same theme and our take on what AutoML agent systems and what zero lines of AutoML will look like or is going to look like, or what's the current landscape. So this is AutoGluon Assistant from the AutoGluon team. My name is Anirudh Dagar. I'm an applied scientist at Amazon. And yeah, let's get the talk started. So quick outline of what I'm going to share today about, first, I think yesterday AutoGluon was thrown around. What exactly AutoGluon is, maybe a little bit of overview would be nice for people who don't know. Initial design and early days of AutoGluon Assistant. We started this project last year, and what we are doing right now, specifically MLZero, which is the new form of AutoGluon Assistant. We'll dive into the methodology, and I'll share some numbers because, of course, like it's good to share some numbers and back what we claim. Those are the results, and then eventually like some challenges that we face and what will be the future work and the road ahead for this project. So what is AutoGluon? It's an AutoML toolkit, and our goal is to democratize machine learning with fast and accurate 3 lines of code. That's all you need. That's what our claim is. To be honest, it's not exactly just 3 lines of code because you need some kind of data pre-processing always to get it into the right format. But more or less, it's the modeling part, which is 3 lines of code, and that's mostly all you have to know from the AutoGluon API. And we support tabular data, we support time series, image, text, combine all of them, get multimodal data. All of that is supported in AutoGluon. It has a simple API, as I said, like to quickly build the models. Even for people who don't know anything about machine learning, it's quite easy for non-experts. And for the tabular specifically, we combine state-of-the-art ML techniques like stacking and ensembling, and there are tons of other things that we do, which are very popular in the machine learning community. For tabular specifically, it's more like what has evolved through these Kaggle competitions. That's how AutoGluon was started. The story was like we participated in a Kaggle competition. We learned that there are so many hacks that you have, and we put together all those hacks into like a very messy, not so good looking package, and that eventually, when we structured it better, refactored it, added more functionality, that's what AutoGluon is now. And the best thing is it's open source. Anybody can use it. Available on GitHub. Just try to search for AutoGluon. So a bit more about like how effective AutoGluon is. I mentioned yesterday, I think last year in 2024, out of the 21 tabular Kaggle competitions, 17 of them had a top 3 finish where AutoGluon was being used. It's not just AutoGluon. It's not that like you use AutoGluon and eventually like you get a podium finish. Of course, if everybody starts doing that, everybody will get a podium finish, which is not possible. But it is AutoGluon plus some other kind of hacks that people have been using. So these are the list of all those competitions. You can refer to the GitHub repository and look at what people have been doing with AutoGluon on top of AutoGluon to achieve podium finishes. And all of these, on average, had like 1,500 human teams competing in these competitions. And apart from that, like inside Amazon, we have this team called Machine Learning University, and the primary goal is to democratize the education of machine learning to people who are still new to it, and try to like make it easier for the Amazon software development engineers to learn ML, and it's been taught to over 26,000 Amazon software development engineers, and AutoGluon is one of the key toolkits that is being used for the machine learning university team. It's also been deployed in over 800 Amazon projects, used by over 200 companies, including NVIDIA, Intel, Capcom, many more. And yeah, that's basically a brief overview of the effectiveness of AutoGluon and what AutoGluon actually is. But today, my talk will not focus on AutoGluon itself, but what we are doing to take a step forward to zero code AutoML, or like completely hands-off AutoML. And for that, like, we need to understand what the current landscape is. And the current landscape, as I mentioned, AutoGluon might be or is the ML community's go-to tool for computations. You just need 3 lines of code, and on top of it, maybe some other technical setup. That's one of the go-to tools in the AutoML community, but it's still not completely hands-off. It's still requires some human manipulation of code and like things other than just those 3 lines of code to actually build a very, very nice deployable model. And then there are these AutoML agents, which were like talked about a lot yesterday. So all of them have a few things that are concerning. Like most of these agents, I think it was not mentioned, but most of these agents still require some manual work, specifically in the pre-processing stage, because usually when you get the raw data, it's not clean and it's not pre-processed. You don't expect the data to be in a particular format in all the cases. Maybe for tabular, yes, but even in tabular, like, you can get data sets in very messy random folder structures with different file types and whatnot. So all of that is still something that AutoML agents, which are LLM based or not non-LLM based as well, are not able to completely handle without human intervention or expert help. And other than that, like, these agentic systems, they are like computationally expensive in terms of you definitely need some sort of an LLM, and of course we know what the cost of running LLMs are. And then there are code generation limitations and the LLM limitations that we are all aware of. But I will also talk about this in detail a little bit further down in the talk. So towards this zero code AutoML, we wanted to like do our part and like move AutoGluon towards this. And for that, like, we started with this particular very, very, I guess, unknown diagram that nobody knows, which is the machine learning pipeline, which I guess is thrown around everywhere. It's the raw data that you get. You have a machine learning expert which has to plan and task what will be done on that raw data. Then there might be data cleaning, there might be some features that are generated, and of course, like, after bazillion models are tested and different hyperparameters are tuned, eventually you end up with a model that is deployable, right? That's the entire pipeline. And currently, most of the AutoML systems have been focusing on model building and tuning. Some of them recently have also been now focusing on the feature engineering part, like Caffe. I will also talk about Caffe later, but more or less the focus has been only on parts of the pipeline and not an end-to-end solution, even though the agentic systems claim to be like end-to-end, but they are not really end-to-end. As I mentioned before, like, there are some pre-processing issues and other issues with them. So the dream of pointing an AutoML system to raw data and getting a deployable model with not just a black box, as Vilash mentioned yesterday, maybe a gray box kind of approach, which also shares like what has happened, what are the artifacts, what was the code. That would be nice to have, and eventually, like, you get your predictions, of course, and a deployable model that is ready to use. So that's our vision, to have the input as the raw data directory, plus some natural language description about what the data set is or what the problem is, and what the user wants from the deployed model in the end. So in the process, we want to build a system which is fully automated and works with like reasoning and execution of all of these middle steps that are involved in the pipeline. And eventually, like, we output trained models, deployable artifacts, and the human effort is just that you describe what you really want to achieve. So to this, we introduced AutoGluon Assistant last year in November, and this was the first step. It was still like early days. We've been experimenting with this. We've been also using it secretly in some open challenges, which I'll talk about later. But what exactly AutoGluon Assistant in the initial version was just an LLM interface to solve tabular ML problems using natural language description, very similar to AutoDS, which was mentioned yesterday. And even the approach was coincidentally like very similar. So I might not like go into all the details here, but I will still like talk about a little bit of what we are doing. So the input is the dataset description and the CSV files or the tabular formatted data files, which can come in different formats. Could be training data, test data. Sometimes there are also multiple tables of these data sets. And how do we interact with AutoGluon Assistant? We also wanted to build a simple user interface for people who have not really used any kind of terminal, or I guess like are not used to programming languages. So for them, maybe like some business experts who just want to like get some predictions out of it, which can then be fed into another model to like produce some analysis or just get the numbers. Would be nice for them to have a web UI, which is like a simple drag and drop. And for that, we built like a very basic AutoGluon Assistant web UI. This was the initial version. Right now, we are building a second version of this based on the newer method that we have. But it looks something like this, where you just have some configuration that you can choose. If you also leave it to default, that's fine. You can upload a data set or choose some of the sample data sets that we already have if you want to just demo things, and then input the data set description or the problem description in this, or you could just upload it as a file as well. And all of this is was released in 2024 in November, and I mean everybody is free to use this on GitHub right now. So what the design of AutoGluon Assistant in those early days looked like was basically like we talked about the input and the output, but what happens in between is this three-step process, which is like task inference, feature generation, and predictive modeling. Task inference is the main, I guess, step where we are extending or where we are taking those 3 lines to 0. The way this works is that you basically try to pass the information that the user provides in the problem description or the data set has. For example, what are the label columns, what you want to predict, what kind of evaluation metric you want to use, and what are the columns that you might want to drop, like ID column or some other columns that are missing in the test set and are available in the train set. So those are also something that you need to take care of. And all of this happens in the task inference. This is then like this works based on some LLM APIs that we call and try to infer stuff. And there is not just the LLM that's going to do this, because we wanted it to be a bit more reliable than whatever the LLM throws at us. So we also have some logical checks to make sure that whatever the LLM is predicting is it's not completely like hallucinated or random, right? So that's the task inference step. Then there was this feature generation step where we try to use different models that are already available to generate features, looking at the description of the data as well as like what the training data itself looks like. These include Cafe, OpenIFE, and we also tried out other things like DFS. I will not go into the detail of this particular module of AutoGluon Assistant, because in our initial experimentation we saw some benefits, but there was no clear evidence of like if this really helps. And the problem is like very tricky in this particular space because feature generation can also be achieved by just some sort of stacking and ensembling. You can think of those as new features. You can also think of every new layer in a neural network as building new features on top of what was available. So it might be the case that the features that are crafted through these models are already covered in those kind of scenarios. And in that case, like you are basically adding just duplicate or repetitive columns in your data set, right? So in the end, like we couldn't find like a very strong evidence of using this, and we still have it in beta, but it was never like something that we could rely on, like it always works or something like that. And then the third and final module is the predictive modeling module, which is basically a wrapper of AutoGluon itself and calling AutoGluon tabular using all the information that we have inferred until now from the task inference step. If we have modified the features in the second module, feature generation step, and this then produces the submission outputs, which are then formatted according to the way that the user has asked them in the initial input prompt, and those are then like there for you to like submit to Kaggle. And we also built a very simple interface to directly submit from AutoGluon Assistant to Kaggle, and this is what the very first version and the initial design that we had, and this is what was released then. I think I already went through task understanding. Maybe I can just go through like what exactly is it that we are doing here. It is automatically identifying the data and description files, because these description files and the tabular data might be like, it could be anything. You just give a folder or a directory to AutoGluon Assistant, and it's our job, or the LLM's job in this case, plus some logic to identify what those data and description files will be, and then the problem that you're solving, how to measure the success, what kind of data set it is, label column, ID column, as I mentioned. This is something how the example of a task would look like. You have the train.csv, test.csv, description.txt, and this is an example of like how the descriptions might look like. Let me just read out one of them. The data set presented here, the crab age data set, which is one of the playground series data sets from Kaggle, comprises a lot of both categorical and numerical features. Your task is to predict the age item. The evaluation metric is mean absolute error. So that's all the information that you need to provide to AutoGluon Assistant, and eventually the API integration of AutoGluon, that's the third module, will use all of these information that you've inferred till now, and we already have let's just say like a boilerplate kind of a template where we plug all these parameters that we've inferred into AutoGluon tabular and let it run with some specific settings, which can be configurable through AutoGluon Assistant's config files, but you can also let them run in the very default setting by just letting AutoGluon Assistant know how much time you have and what kind of compute you have, and based on that you can decide like what kind of preset do you want. So I hinted a little bit about us using AutoGluon Assistant in secret for this particular competition, even when it was not released. Kaggle AutoML Grand Prix, I think it was one of the first AutoML specific challenges on Kaggle, even though like it was not completely agent friendly because we had humans competing in it. But what the competition was is like it's a 5 competition series where entries were ranked on the performance in the first 24 hours of the competition, because these Kaggle competitions usually run for sometimes months, even longer than that, sometimes days, but only in the first 24 hours if you want to produce something useful. The idea was like maybe it's best to use AutoML techniques, but you are not constrained to using AutoML techniques. Humans are allowed to do anything they want to do. The goal is just that you will decide the leaderboard in the first 24 hours for this competition. So the Grand Prix attracted over 300 different teams and a lot of popular AutoML solutions, AutoGluon, H2O, DAI, Llama, all of them were featured. And we entered the competition with team AGA, which used AutoGluon Assistant to make submissions, and all of these submissions were made like without any kind of human intervention. So even before a competition was started, for example, the competition starts on the 1st of every month. We already had decided these are the 5 specific configurations which we want to run AutoGluon Assistant on. AutoGluon Assistant at this point of time has not looked at the data, doesn't know what the competition is about, doesn't know what the structure of the data sets will be, and all of this is already logged in. And when the clock hits 1st of the month, AutoGluon Assistant automatically then gets the competition description, the data description, the problem description, downloads the data sets, and runs those 5 configurations that we have already pre-decided. Those 5 configurations were 5 because you are allowed to make 5 submissions at max in 24 hours in this competition. So notably, in the 4th competition of this 5 competition series, we had one of the configurations where we were using Cafe, which is one of the feature generation techniques, and we were using it with AutoGluon 12-hour run with the best preset module, and this resulted in a 2nd place in the competition. And like, let me just highlight what this means, because all the other teams in the competition were human operated, or humans were basically like in the loop, and this was basically the only submission which had like no human in the loop. And to be honest, like I was myself surprised, like we were expecting good performance, but not expecting to be 2nd placed in the competition. Overall, like we ended up 10th in the leaderboard, which speaks a lot about this initial setup of AutoGluon Assistant. And yeah, notably, like the other team from the AutoGluon team, which was also participating, which was human in the loop team, Nick and Leonard, kudos to them. They finished 2nd place overall at the end of the competition. So that speaks a lot about like this initial version, but I shared what the vision of AutoGluon Assistant is, and it's a complete end-to-end solution where it's not just tabular data set, right? So how do you go beyond what we already have? What about other modalities? What about time series? What about image, text, and like having multimodal data sets? How do you handle that? What about unstructured and unprocessed, not clean data, which is usually the case in most of the machine learning pipelines? How do you handle that? And can we also leverage ML ecosystem outside AutoGluon? It's not just AutoGluon that's like a library in the ML space. There are so many other libraries, and all of them might be good at a particular field and a particular domain. So what if we have a system which is able to leverage all kinds of machine learning libraries and not just AutoGluon? And that's exactly what we've been working towards now, and that's what I will be talking in the 2nd half of my presentation. So coming back to the state of the current ML agents, which I briefly touched before, most of them need this manual configuration and expert input. This is typically data pre-processing, as I mentioned. The raw data that you get is where like these agents are tripped off, and they're not good at like handling or automatically perceiving and understanding what the raw input is without any human guidance, or like without the raw data being in a strict format. And example can be, a good example can be when you have a folder, say customer feedback, which has a lot of documents, which has text files, some images, and you just have that to figure out like a sentiment analysis task that involves all these different kinds of documents, which has a very arbitrary folder structure. And in that case, all these ML agents, you cannot just point the raw directory to it and get the agents to work. So there is a step of pre-processing that is always involved, which is probably not talked about as often. And we wanted to like work on this particular step as this is like part of the pipeline. And then the other problem with the current ML agents is that most of the solutions that are either produced rely only on the internal parametric knowledge of the LLMs, and they don't really like make use of the current library. The APIs that they're using in the code that is generated are probably not using the current library documentation, and these libraries keep on evolving. The APIs sometimes break over time with new versions, and this can like lead to a lot of issues in the code generation process of these ML agents. And other problems include API hallucinations. I'm sure like all of us have seen this. I mean, I have definitely seen this whenever I try to like get a specific library working through LLM. I want something generated from the LLM. I give it a prompt, and it automatically comes up with a very nice API which doesn't even exist in the actual library. And that's one of the problems where these current ML agents definitely fail. There are some edge cases which they are not good at, again, because of this knowledge gap between the actual current library documentation and what they know. And then there is, of course, this LLM problem, which basically the LLM performance degrades as you have like long and complex context. This usually happens when you are tracking the errors of the iterations that you run of the agent, and these errors are being added every single time to the prompt, and over time the solution is trying to improve itself, but because of no efficient memory mechanism, most of the ML agents fail at this case as well. Some of them have tried to solve this, but more or less like I don't think they are still good enough because they are not doing it as effectively as it could be done. And then another like problem would be the template-based implementations, which we also had in the first version. Is that with a template, you're always like working with a fixed format and a fixed code skeleton, and the flexibility that you could achieve without using any kind of template is something that is also left in this case. So to overcome all of these issues, we introduced MLZero this year. Very recently, just last month, we open sourced the code and also put out the paper on archive. Currently, it's under submission. What exactly is MLZero? The central part of this figure is what the agent looks like. It's an end-to-end multi-agent system that integrates specialized perception agents with dual memory modules, semantic and episodic, to run iterative coding cycles, transforming raw data into ready-to-use models with prediction outputs as well as code artifacts without any human intervention. So this is our take on the agentic ways to solve or like to achieve to move towards 0 lines of code. And now I will be talking about like what exactly we are doing differently and how is it better than the current landscape of the agents. So MLZero has 4 different modules, and the entire architecture has been inspired from like how a data scientist would look at a particular problem, a machine learning problem, and try to solve it. So take an example of you being a data scientist. The first thing that you do when you get a problem is, of course, you read the problem statement, but the first thing is usually you look into the data set, you open the files, you look at the structure, you try to understand what the data set itself is about, and after that you make a plan like what kind of library you want to use for this data set. Maybe it's a tabular data set, you want to use scikit-learn, you go for scikit-learn or XGBoost or something else. If it is a, I don't know, like a vision-based task, you probably use Torch Vision or some other library for vision like TIM, right? So it's based on what the data set is and based on what the problem is that you will plan and decide what kind of library you want. And that is like the first step, even before you start implementing anything. And this happens subconsciously, I guess, as a machine learning engineer or a data scientist. And then the second step is that once you know that you will be using this particular machine learning library, I mean, most of us like won't be writing everything from scratch because we already have these nice libraries which are pretty useful. But once you know these machine learning libraries that you're going to use in your implementation, you would want to know like what the API is. You can't just go out and like, I'm going to use this machine learning library and hey, AutoGluon, give me this. Maybe AutoGluon can do that, but not everybody, all the libraries can do that. So you definitely need to look at the API, try to understand it. So it's like referring to a book, which is similar to ML Copilot. I think yesterday was had a similar external knowledge base, but you can think about this as an external knowledge base. This is the second module called the semantic memory module, which is enriching the system with the knowledge of ML library and its documentation in this case. And then once you know the API, once you have a bit of an idea of what the data set is, then you start implementing stuff and you write code. In this process of writing code, you will end up with errors, you will end up with issues, you will end up with like different iterations of your model. You will probably like start with a very basic model and then eventually like move to more complicated things. And in that process, like you also have to have some kind of way to like keep the context of the last iteration that you took, where you had faced like some issues, like the errors that you were getting, what were the outputs of the model that you were getting. So all of that needs to be considered as well, which is taken care by the episodic memory module, which maintains a chronological execution record of whatever has happened in a particular iteration of coding. And this is then utilized for debugging the next, debugging and helping in the next cycle. And all of this is like iterative coding, of course. So this particular figure has the left-hand side, or the top left, is the perception module, where you're trying to understand what the data set is, what it looks like. I will talk about it in detail. The top right is where the semantic memory module lives. Bottom left is the iterative coding cycle, which is kind of the heart of the agent. And on the bottom right is the error analyzer agent, or the episodic memory module, which is basically helping the iterative coding module. And all of this can be seen like in the middle, how it goes. From raw data, you have the perception module, you select the ML library, you have the episodic memory and semantic memory initialized, then you go into this iterative coding cycle, and after, like, if there are any errors, episodic memory will help you there. You retrieve some knowledge from the from the semantic memory, and based on all of both of these two memory modules, you will eventually, like, hopefully end up with a nice output which is ready to deploy, and like you could use it for making submissions to different competitions and I don't know what not. Outside Kaggle as well, there is a lot of things that you can do. So particularly for the perception module, there are 3 different agents. You can think about the entire system as a team of agents which is specializing in different tasks and trying to achieve like different things at the same time, running in parallel or sometimes in sequence, depending on what the job is. In this case, like the first thing is, like, we try to group different different and similar kinds of files in a certain file structure. We try to read different files, what the dataset itself looks like, and understand the dataset characteristics. And that's the job of the file grouping and file perception agent. Then this information is fed to the task perception agent along with the user's instruction, and all of this then brings together this one document, which is what initially we were using to guide the LLM, but now like based on the file grouping, file perception, and the task perception agent, we build this one single document which has natural language description about what the ML task is. And this one is similar to how the task inference step was before, but like in two different steps. And the first step is where a lot of pre-processing issues and with the raw data are being solved through the file grouping and file perception agent. And the third and final step, once you have that document ready, you can pick and select a specific ML library. We have a list of libraries which are already registered. You can add more if you want to, but out of those, like depending on what kind of task you have, you just pick one, and that's the job of the ML library selection agent. So that's the first module, perception module. The second module is the semantic memory module. This is done offline, and even before like any kind of iterative coding cycle is done. This is a separate module which automatically will take up the documentation of all the libraries that you have in registry and summarize them and condense them, which will then be used later on in the iterative coding cycle for retrieval. So this is what the semantic memory module looks like, with 3 different agents all trying to simplify this documentation that we have for the machine learning libraries and its APIs. And we also focus specifically on the tutorials and more code examples in the documentation itself, not only like all the documentation files, which might not be as useful. So the semantic memory module is very helpful in guiding the coding agent. And the third module, which is the episodic memory module, is simply a module or an agent which tries to analyze the current logs and the code that has been run till now, and tries to analyze the errors if there has been any. And the output of this particular agent is just the error summary. Instead of the entire traceback of the errors, it's just the error summary and also a small suggested fix for the next coding cycle. And all of this comes together in the iterative coding module, which has a code generator, which is built on top of a coding prompt, which goes into the LLM and that generates the code. And with the help of all of these 2 memory modules that I mentioned before, and the perception module basically helps solve the first problem of raw preprocessing data set. And all of this is then eventually like made available in terms of bash script and a Python code file, which is then executed. And all of this runs for n steps, which can be defined, usually like 5 by default, and depending on the success and the failure, which is also not just the return value of the program. It's not just return value 0 is a success, it's more than that. Like how good is the solution quality is something that we check, and based on that we have the end of the cycle, and that's the output for this. And now I will quickly like show you something that is still in the works. So this is very recent. We will be also open sourcing the UI of the new version of AutoGluon Assistant in the coming weeks. But this is a quick demo where you can see how it works. I will not run it for the entire 4 minutes of this video. Maybe a bit shorter would be nice. So the user only defines what the time limit it wants for the program to run, and then I'm sorry. Yeah, that's okay. Maybe I think it's easier if I just move. Yeah, I think it's really tricky. Yeah, so you just define the time limit. You have a directory with the data set, in this case, spaceship Titanic data set, which is very simple data set. It has a description file of what the data set looks like, and also It has like the tabular files for the training and the test set. And as soon as like you start, the perception module kicks in, tries to understand what the data set looks like, groups the files into, in this case, like 2 different patterns have been found, which is basically tabular and the description file. So analyzes that, reads that, and once that is done, I think it picks up a specific ML library for the task. In this case, I think it picks the AutoGluon library. We should also log that, and that kicks off the iteration cycle 1. This will go on, and eventually, like based on the number of cycles that you set, or based on the success we achieve on the total number of cycles, you will get an output which can be visualized in this case, and the code that is also generated is available to be to download in this case. But all of this will be available very soon. But for now, if you want to use AutoGluon Assistant, a simple command line interface exists. MLZero, that's the command, and include the directory. That's all you need. If you want, you can also provide some instruction. But other than that, I think this particular UI will also be available very soon. So back to the slides. Yeah. So now I will just share quickly some results about MLE Bench, which is another benchmark which has more or less now become something that has been used by a lot of these agents. So we also have to compare to MLE Bench. That's just how it goes, even if MLE Bench might not be the best benchmark. In this case, we have MLE Bench Lite results, which is an existing benchmark comprising of 21 diverse Kaggle competitions, and these have like different modalities, and the goal is to measure like how well the AI agents perform at ML engineering tasks. We look at this particular diagram, and it's not just the amount of gold medals or silver medals or bronze medals that are won by the agent. We also look at the rank of the agents, so compared to other agents, where does our solution stands. So overall, the average rank for MLZero was 1.43 compared to the others, like far better. And also the success rate of MLZero eventually like emitting output in those n iterations was 86%, a little bit better than the previous state of the art, which was IID in this case. And overall, we also achieved like more number of medals, but I don't think this is like a good enough metric just to like judge a particular agent on, because MLE Bench itself has some limitations, and those limitations are like specifically mentioned here. So pre-processing, as I mentioned, MLE Bench always provides you with clean and pre-processed data. So it has some scripts that you run on the raw inputs, and this would simplify the ML workflow. And sometimes this might overestimate what agent is capable of doing in real world scenarios. The other problem is that these baselines, specifically like the number of medals that you're winning, might not be the best thing to look at, because some of these competitions are maybe 10 years old, and at that time some the outdated human baselines are probably using older compute. Some algorithms were not available at the time, so maybe like it's not a fair agent to human comparison, and the medal winning thing looks nice and sounds nice, but might not be the best thing to look at. But I guess like that's the only way to look at Kaggle competitions. If you are a grandmaster, or like if you're winning a specific medal, or if you are top N%, it is definitely representative of how good you are, but it is not representative of how good the agent is compared to the human comparisons in that case. So to alleviate those issues, we introduced multimodal AutoML agent benchmark, which is another benchmark which has 25 diverse data sets, and this specifically focuses on the accurate assessment of a particular agent by different the limitations that I just mentioned in MLE Bench, specifically the pre-processing part, and also like not specifically looking at the medal counts, because these competitions are beyond Kaggle and they span various data modalities even further from what MLE Bench covers, including multilingual, multi-table, multi-label, zero-shot inference scenarios, which are all probably like not all of them are present in MLE Bench. And in this case, when compared to the current agents which are very popular, MLZero completely dominates the space with highest success rate, 92%, and the average rank, as you can also see, is much better when ranking the agents. The other three things that are important, which we also looked at, which most of these agents are not really considering, is the use of smaller LLMs. And I think a lot depends on what kind of LLM you use. And eventually our goal is to have a very robust agent which can be run using a very small language model. And in this case, we used Llama 3.1 with 8 billion parameters. I was about to say only 8 billion parameters, but then I checked my words. So 8 billion parameters is less for large language models. And even with using that particular LLM, we had a degradation in performance, but the success rate still is comparable to the other agents in multimodal AutoML agent benchmark. And the average rank is also not too bad and is comparable to the other agents, as you can see in this case. Otherwise, because this whole LLM API calling is computationally expensive, we also managed to have a significantly faster method that uses lesser number of tokens in certain scenarios, and that is another thing that we are trying to strive towards and move towards, like the computationally efficient multimodal agents like MLZero. And then of course, like the entire system helps us eliminate errors which were initially caused in the perception phase or the post-processing phase, or errors which were due to API hallucinations. So all of this is alleviated using the dual memory architecture. And yeah, I think with that was MLZero, but there is still a lot of work to do in the future, and there is a long road ahead for us as well as the AutoML community, specifically enhancing the performance with smaller language models. And in the cases where the ML libraries that you're trying to use might not have enough documentation, which is a valid case, in that case MLZero is not as effective. So what can we do in those cases? As I said, like we do not want a black box method. We want something which is assisting the human and helping us build models. So we would want humans to collaborate with these kind of agents in the different steps, and that could be like one of the modes where you run MLZero or AutoGluon assistant, and that is something that we are also looking at right now. Scaling up with more APIs, exploring the expanding the data scientist tasks across more domains and modalities is something that we need to do. And of course, like this came up yesterday, which is another thing that we've been bugged with, is the benchmark contamination and plagiarism. How do you handle LLMs that have probably already seen most of the data that you are using in these benchmarks? So the benchmarks should be representative of how good the agent is, but if the LLM already has seen some of it, might not be very true. So this is a problem that we've not solved yet, and going forward, I guess like there should be some effort from our end as well as like the AutoML community to look at this. So yeah, that's AutoGluon Assistant. You can go ahead on GitHub, AutoGluon/AutoGluon Assistant. It's completely open source. Feel free to contribute if you want to install. I think pip install AutoGluon.assistant. The newer version might not work with this, but the older version will. the newer version will also work in a few weeks for sure. But otherwise, you can look at the README and start playing around with this if you have some sort of a LLM that's a requirement for sure. But otherwise, yeah, feel free to check it out. And if you like the project, please feel free to start it. Of course, I cannot end the talk without acknowledgements. My team at AWS, the AutoGluon team, we've been working really hard towards this. So all of them have collaborated on this project. And yeah, special thanks to the AutoGluon team, the AutoML community, and the open source contributors, which continue to make AutoGluon ecosystem better. And also, like in this case, Kaggle was a big help for us for benchmarks, as well as the Kaggle Grand Prix. And of course, AWS provided all the computational resources for this study. Yeah, thanks a lot, and I hope you can start using AutoGluon Assistant.